well. Let's go ahead and get started. So first, I just wanted to share, especially for those of you who are new to GMAT prep, if you are looking for other opportunities to study the GMAT for free, we offer a couple of them. One of the best ones is you can come to session 1 of any of our GMAT classes for free. So we offer in-person classes in most major cities, and then we also have online classes happening all the time. And they are 9-session courses, but you can come to the first session, which is 3 hours long, a really informative session that covers important understandings of how the GMAT is scored, important understandings about timing, and then also data sufficiency and sentence correction strategy. You can attend for free. You can also try our GMAT Interact, which is our adaptive GMAT study video feature, which is available on our website, and you can check that out for free. So lots of goodies out there for you to use if you're looking for free resources to study. Here's the game plan for today. We are going to be focusing primarily on quant, and we're going to talk about one of the most heavily tested and fundamental topics on quant, which is fractions, decimals, and percents, or as we like to call them, FDPs. They need an acronym because they're so common on this test. What we're going to do today is do about 6 or however many we have time for real questions that will show you how the GMAT likes to test fractions, decimals, and percents. And from each of those questions, we're going to learn things like the mechanics that the GMAT likes to test, as well as the strategies that we can use to approach these questions faster. So we're just going to dive right in with the first question. If you don't already have it, you might want to take a moment to grab a pencil and paper. When I put the first question on the screen, I am going to give you 2 minutes to solve it, and I'll hop off the video so that you don't feel the pressure of someone watching you. That is because for those of you who are new to the GMAT, there are 31 questions and 62 minutes on quant, which means you have exactly 2 minutes per question on average to solve them. You don't necessarily spend exactly 2 minutes on every question, but I like for my students to get a feel for what that 2-minute mark is like. So I always time students when they're working on problems. So I will time you for 2 minutes. And then when time is up, I'm going to send out a poll asking you to share the answer you got for this first question. All right, here it is. Give it a shot. All right, you've got a poll coming your way. That is 2 minutes. I'd love to get a sample of what everyone thought. Okay, awesome. Thank you, everybody. So it looks like we are starting off strong with this problem. A lot of you selected answer choice B, which I will go ahead and tell you is the correct answer. So nice work if you got that. This is a question that is definitely testing your fundamental knowledge of the mechanics of FDPs, in particular, your ability to work with fractions. So one of the things that you want to do is just get really comfortable with those mechanics so that they come quickly and naturally to you, and you can do that through lots of different drills. This particular problem is a little intimidating looking because it's a fraction within a fraction within a fraction. It's like the inception of fractions. And so there's a couple of things that I want to mention that might add some value to your work on this problem, even if you got it right. The first thing is if you are doing any GMAT problem, one of the best things that you can do is take about anywhere between 15 to 30 seconds at the start of a problem to take a glance at the problem and the answers, and to think about strategy and common sense eliminations. So when I glance at this problem, I say, okay, I know that I'm going to need to do some work to get some common denominators and just kind of crunch out the arithmetic on this problem. I might want to think about what's going to be the fastest way to do that. I also notice that my answer choices, even though they're all fractions, they are kind of spread apart in an important way that might help me to estimate, to eliminate some answer choices and increase my likelihood of getting this right if I need to make a guess, and also help to prevent myself from making a careless mistake by eliminating answers that are definitely wrong from the get-go. So here's how I would think about that. When I look at this question, I say, okay, I have a fraction. I want to think about the numerator and the denominator of that fraction. And in general, a helpful estimation tool is to start by thinking, is my fraction going to be greater than 1 or less than 1? So if I have a fraction where the numerator is smaller and the denominator is larger, then I know my fraction is going to be less than 1. If I reverse that and I say, okay, numerator is larger, denominator is smaller, then I know my fraction is going to be greater than 1. So a quick comparison can help us eliminate some answer choices. So if I do some thinking on this fraction, I say, okay, I've got 1 on the top, and then I've got 1 plus something. And I don't know what that something is going to be, but it's positive. So it's going to make the number on the bottom bigger than 1. So I'm in this top scenario where the numerator is smaller, the denominator is larger. My answer needs to be less than 1, which means right off the bat, I can eliminate D and E, which are both greater than 1. One nice thing about that is you'll notice that D is a trap answer. It's the sort of flip of what we have for our correct answer, B. So you can imagine that there might be some kind of arithmetic mistake that would lead you to choose answer D instead of B, even if you kind of got the concept down. And so doing some of this common sense thinking can help you rule it out so that if you end up with 10/7, you're like, wait, but that isn't logical. Let me check my work. You might also think, how much bigger or smaller is the numerator than the denominator? I've got 1, and then I'm adding a small looking fraction to 1. So I'm imagining that this is going to be a number where the numerator is not that much smaller than the denominator, which means it's going to be kind of close to 1. So I might tentatively say, I don't really think this is going to be 3/10 because it looks like the denominator is only getting slightly bigger by adding a fraction to it. So just by doing some common sense thinking, I've narrowed it down to B and C and lowered my odds of making an arithmetic mistake that would lead me to the incorrect answer. Michael, I see your question, and I'll get to it in just a minute after we finish with this problem. Okay, so if we're down to B and C, and we start crunching some arithmetic, I'm sure a lot of you have a great way that you went through this problem. And I just want to show you one way that doesn't always come first to mind, but that can be helpful in saving time. So I'm going to rewrite the problem here. And the strategy that most folks, or that pops into most folks' heads first, including mine, is, okay, fraction within a fraction. First thing I need to do is find a common denominator. So I'm going to convert this. This is 1/3. 2 will become 6/3. I'm going to add it. Then I'm going to find a common, or I'm going to divide 1 by the answer. Then I'm going to find another common denominator, and I'm going to keep working through. And that'll work. That'll get you to the right answer. One thing that you can do that might be a little bit faster is to take the step of saying, okay, I've got a 3 in my denominator that I want to get rid of. So to make my work move a little faster, I'm going to go ahead and multiply this whole big fraction by 3/3. So I'm multiplying this whole fraction by 3/3. And what that's going to do for me is help me move a little faster by skipping some steps. I'm essentially multiplying this fraction by 1, so it doesn't change the end result at all. It's a totally legal arithmetic move. But I end up with 1 + 3 over, and then I see I'm going to distribute this 3 to get 6 + 1. So in my head, I can say, okay, that's going to be 7. And now I have to get rid of a 7 in the denominator. So I can do that same move with the entire fraction. And I'm going to end up with 7 as my numerator. 7 times 1 is going to be 7, plus this is going to cancel, and I'm going to get 7 + 3, which is 10. 7/10. So this particular move of identifying what you need to get rid of for your fraction and then multiplying by that number over itself in order to make the math move a little bit faster is a nice one to help you with these fractions within a fraction. All right, let me know if you have any specific questions about this problem or any of those strategies that you just saw. And while you're putting those in the chat, I'll take a look at Michael's question. So Michael says, are certain topics more likely to be seen at certain levels than others? For example, permutations of 600 to 700 versus 500 to 600. Michael, I would say yes. There are some topics like quadratic equations, combinatorics, which includes permutations, like you just mentioned, probability, that tend to come up when you're doing well in the quant, and so that tend to show up at that higher difficulty level, but that you might not see if you're hanging out in the 500 to 600 level. Yeah, that's a great question. Because of that, we often encourage students to sort of level up in their studying. So if you are working on moving from a 500 to 600 score to a 600 to 700 score, and quant is one of your main, areas of need, then you might want to focus more on fundamental topics like fractions, decimals, and percents, which is what we're working on today. But save things like combinatorics, probability, quadratics, the more challenging topics for when you do reach that 600 to 700 level, and now you're looking to move to the 700 to 800 level, or more specifically within quant, when you're getting into the 40s. So maybe when your score is, 45 or so, and you're trying to still boost it even higher, is when you might start moving into more advanced topics. Quadratics, you could probably start a little sooner, but combinatorics and probability are not super heavily tested. So you want to save them for when you're the most likely to hit those topics. All right, I'm not seeing any questions about this particular problem. So I'm going to go ahead and move us along to the next one. Same deal. I'm going to give you 2 minutes to solve it. Here we go. All right, new poll coming your way. Okay, awesome. Thank you to everybody who pulled in their answers. Okay, so the correct answer to this one is A. A lot of you got this right, which makes me want to mention an important reminder. Anytime that you see a question that to you looks easy on the GMAT, what you want to do is slow down and get it right. One of the big strategic errors that many people make on the GMAT is they see a question that looks doable to them. So maybe you looked at this question and you were like, great, I'm going to know how to solve this problem. I can do it. And they say, okay, let me solve it as fast as I possibly can. Let me go through this problem really quickly so I can save time for harder problems. The concern that comes up with that is if you rush through an easy problem, you increase your odds of making a careless mistake. And if you accidentally make a careless mistake and get an easy problem wrong, the consequences on the GMAT are pretty severe. The GMAT then thinks that you can't do an easy problem, and so it notches the difficulty down even more. And it's a much more severe impact on your score than if you miss a harder problem. If you miss a harder problem, the GMAT is like, okay, most people are going to miss half of these harder problems. I'll give them a slightly easier one, but still in the high difficulty range. If you miss easy problems, you're not going to make it to the high difficulty range. So you see a problem like this, you think you know how to do it, you want to slow down and make sure you're super careful about it. All right, so this one is pretty straightforward. If we look at our initial fraction, x over y equals 2/3, we're basically being given a ratio. So it is possible that the literal number of, or the literal value of x or y could be something different than 2 and 3, but 2 and 3 should work. So x is going to be equal to 2, and y is going to be equal to 3. The simplest way to solve this problem is just to plug those values in. 2 minus 3 over 2. It's going to be equal to -1/2. Mistakes happen if, for example, you put the value for y on the denominator of this fraction, then you would come up with -1/3, which is another trap answer. That is right here. Or maybe you accidentally reverse the values for x and y, and then you come up with +1/2. So just be careful that you are moving slowly enough to solve problems like this and show the GMAT that you know how to do them. If you have any questions, throw them my way. If not, we're going to move on to the next one. All right, here you go. All right, polls coming your way. Send me your answers. Awesome. Thank you to those folks who sent in your answers. So this problem, like a lot of word problems, is all about organizing your information well, making sure you understand the problem, and then solving effectively. So when I look at this problem, I see that we've kind of got this split between money that has been invested in certain ways, and then we've got this remaining $10,000. So if I think about organizing my work for this problem, I might say, okay, we've got the money used so far. We're going to say we've got half of, let's say, T for the trust fund plus 1/4 T, again, for the trust fund, plus 1/5. T for the trust fund is what we've used. If we put all of that over a common denominator of 20, then what we're going to find is that so far we've used 19/20ths of our trust fund. If we've used 19/20ths, then the amount of money left is going to be 1/20th of the trust fund. And we're told that the remaining amount is $10,000. So then all we have to do is set up an equation. 1/20th of T equals $10,000. And when we solve, we will end up with T equals $200,000. Nice work on that, everybody. Let me know if you have any questions. Ryan, let me take a look at your question on the previous problem. Is it common for it to be written like that, as in a fraction, x over y equals 230, and then x equals 2 and y equals 3? Yeah, it's not uncommon at all. That's something that you'll probably see on the GMAT. Okay, cool. Let me know if you have questions about this one. No problem. If not, let's take a look at this. All right, polls coming in. Let me know what you think. If you are still working, that's been over 2 minutes, so this would be a great time for you to kind of cut yourself off Okay, awesome. So it looks like this problem, as I expected, is definitely a higher difficulty problem. We've got a bigger mix of answers out there, and it looks like we also have a lot of folks who are still working on solving this problem. I would love to hear from you all in the chat window what your strategy was on this problem. So what did you do to solve it? Hussein, I don't have an official difficulty level for this question. All of these come from the GMAT practice software, which is available on the GMAT's website. So these are the problems that the GMAT puts out as sort of the most realistic examples of GMAT official questions, but they don't publish data on like the percentage of people who get them right. Okay, cool. So I see Andrea is saying figure out what the numbers would be that are indicated at each tick mark and find the common denominator. You could subtract between different tick marks. Cool. Yeah, I love it. Michael and Miguel, I love this idea of using the common denominator of 35. One of the things that can make this problem feel challenging is if you just feel like you have to individually calculate each difference. So if you say, okay, this is 1/7 and this is 1/5, and let me subtract to see what the difference is between those two, then you might find yourself in a situation where you say, okay, wait, is the difference between all of these going to be the same? Would any of them have different distances? How do I know which ones to calculate the difference for? So it's definitely going to be most effective for you if you are able to calculate the distance between all of them. And the most efficient way to do that is to write out a list of what each of these tick marks represents so that you have them down in order. So that's supposed to be a 7. And then take that list and find a common denominator for all of them. So I say, okay, first tick mark is 1/7, then 1/5, then 2/7, then 2/5, then we get 3/7, we get 4/7, followed by 3/5. We get 5/7, followed by 4/5, and then 6/7. Once you have that list, then you want to take a moment to say, let me put all of these over a common denominator of 35, and then start figuring out the distance. And it looks like there were quite a few people who came up with different answers on this problem, and quite a few people who needed more time to work. So I'm going to pause for a second and just give you a minute to try this out if you haven't already. Put these over 35 and see what you come up with. If you change your answer, tell me in the chat window. All right. So if you're working through this, what you're eventually going to find is that you have some tick marks that are 20 over 35 and 21 over 35. So when you subtract them, you get 1 over 35. And you don't end up getting any smaller distances. You don't need to use a denominator of 70 for any of these fractions. So the correct answer is B. Nice work to everybody. Let me know if you have any questions about this one. If this one was one that was long or challenging for you, might be a great question for you to mark to replay in the future. All right, let's try another one. Okay, poll is out there. Go ahead and chime in. Okay, looks like this was a more challenging one. We are split between 4 different answers right now. So let's talk about how to approach this. So we've got a situation where they're telling us that they're going to do a reduction in the staff. So here's one way that a lot of folks will approach this. They'll say, okay, so 1/3 of the staff is clerical. We're going to reduce by 1/3, which means that the new amount of clerical staff will be 2/3 the old amount. So if the old amount was 1/3 of the total staff, the new amount is 2/3, which means it's 2/9 of the original staff, which would get me answer choice B. Does anybody have any concerns about doing it that way? Is there anything I'm missing if I do that? Yeah, Miguel, I like that way of putting it, to change in the total universe. One of the things that tricks a lot of people on this problem, and that it looks like a lot of us fell for on this one, is they say, okay, the clerical staff is changing, but they don't think about how that means that the number of employees is also changing. If we're reducing the clerical staff by 1/3, then we're getting rid of some employees from this total, not just from the clerical staff. So if we think about the overall change that we're looking at, we're looking for the change in the clerical staff out of the change in the total employees. So what I need to do, yeah, remaining employees, I love that, is a great cue that I am not just keeping the same original number of employees. So I'm going to actually need to do some number crunching on this one in order to avoid that mistake. So answer choice B is a great example of a trap answer that the GMAT has laid for us. But if we actually solve this math, it'll work out a little bit different. So we start with, okay, 3,600, 1/3 are clerical. So we have 1,200 clerical to start. This gets reduced by 1/3. So we say 1,200 times 2/3 is going to be 800. And now we want to know what percent of the total number of remaining employees are clerical. So we have 800 clerical who are left. They've reduced it by 1/3. So we've got 400 employees who have been dismissed. So we need to take that 400 out of our 3,600 to get our new total, which means that now our percent is going to be 800 out of 3,200, which will work out to be 1/4 or 25%. Okay, so another great example of a problem that looks easy, that it seems like we all have the math skills to solve, but that can definitely trick us if we are not taking time to understand exactly what the question is asking. One of the things that I learned in my GMAT study after being burned by questions like this many, many times is that I never click submit until I have gone back to reread the question and make sure that I have understood what it's asking me properly. Okay, let me know if you have any questions about this one. If not, we've got one more question that we'll do together, and then I saw Michael had some general questions, and other folks probably do too, so we'll take some time at the end of the session to talk about those. Here is your last one. Okay, final poll of the evening. Let me know what you think. Awesome, thank you. So one of the things that you may notice when you glance at these two statements is that it seems like together you're being given a lot of information. It seems pretty probable that together you're going to be able to solve this problem when you have both statements. Anytime on the GMAT data sufficiency, when I see that both statements together seem like they're probably going to be enough information to solve, I become really wary of what is called the C trap, which is this trick that the GMAT likes to play, where they set up a problem where it looks really obvious that with two statements together, you should be able to solve. And so a lot of people just assume that you need both statements to solve because you can solve with both statements. When it looks like both statements solve, it's actually more likely to not be C. It's more likely that one statement is sufficient alone, or that neither statement is sufficient, or maybe both statements are sufficient alone. But it's almost like the least likely answer to be C if it looks like it's going to be C. So when it looks like it's going to be C, as on any other data sufficiency problem, you really want to slow down and take your time. This problem is an algebraic translation problem where you need to kind of create an equation out of the information that you've been given. So if you start off with saying, okay, the spouse plus, let's just say there's an oldest and a middle and a youngest child together are going to receive $200,000. That word sum helps me know I need to add these up. So let me take a look at the information I'm being given by each statement. So if we look at statement 1, we're given some information about the spouse. The spouse receives half of the sum, so we can just go ahead and calculate that. The spouse is going to receive $100,000. The oldest child receives a quarter of the remainder. So if the spouse got $100,000, there's $100,000 left. Quarter of that is going to be $25,000. Cool. So we know the spouse plus the oldest. That leaves the middle plus the youngest are going to get what's left, which is $75,000. Problem is, we don't know who's getting what out of that. So statement 1 is not sufficient. If you're new to data sufficiency, this might seem like a lot because there's a lot to the format of this particular problem. But one of the cool tools that you want to make sure that you learn to use on data sufficiency is the answer elimination grid. If I know that statement 1 is not sufficient, then the answer is not going to be A or D. I cross off the top row of my grid. And then I move to statement 2. So statement 2 gives me, sorry about that, some new information. Each of the 2 younger children received $12,500 more than the oldest and a certain number less than the spouse. This is interesting because this first is telling me they received the same amount as each other. So M is going to be equal to Y, which means when I go back to my equation, I really just need to figure out what one of those is. So now my question is maybe S plus O plus Y is equal to 200,000. And I'm just trying to solve for Y because I substituted back in. So they receive $12,500 more than the oldest child. So the youngest is going to be equal to the oldest plus 12,500. And then 62,500 less than the spouse. So the youngest is going to be equal to the spouse minus 62,500. What I know now is that I am going to be able to take these variables and plug them back in to be able to solve for a single value. And once I can see that I'm going to be able to plug these variables and solve for a single value, then I don't need to actually solve it. I want to stop as soon as I'm sure that I'm going to be able to do the right kind of substitution. And I'm going to say, okay, this statement is sufficient. If you are curious as to how I arrived at that, I might do something like, say, rearrange each of these in terms of y. So like y minus 12,500 is equal to O. So now I can take that and plug it back in for O. And I can do the same thing with my S equation and plug it back in for S. And then I'll have a one variable equation where it's easy to solve for y, and I know that this is sufficient. So correct answer here is B. Let me know if you have any questions about this problem. Okay. If not, let's take a look at Michael's question, and this is a great time for you to ask more general questions about anything GMAT related, and we'll take the last few minutes to answer them. So Michael asked for tips for pacing in the quant section. Do I recommend immediately skipping questions we do not think we will know to bank some time? Yes, I definitely recommend immediately skipping questions you don't think you will know. I think that's a great strategy. In general, when I took the GMAT, I used Manhattan Prep's yellow pad technique, which is to take your yellow pad that you get while taking this test and divide it up generally into quadrants with multiples of 8 at the bottom. And the way that this works is if I am working on a certain set of problems, each of these squares represents 2 minutes, and I should spend about 8 minutes total on these 4 problems. I'm not always going to actually do that, so I use this number at the bottom as my guide. When I get to the end of this page, if this says 8, that means there should be 8 minutes left on the clock. If I look at the clock and there are 8 minutes left, great, I just keep going. If I look at the clock and there are less than 8 minutes left, then what I'm going to do is as I turn the page and I go to the next question, I'm going to find a question to skip. And that is going to be a very fast skip, as Michael suggested. I need to save that time as quickly as possible. So I'm just going to say, okay, I'm a little behind, not going to do that question. Go ahead and take an educated guess or even just a 0-second guess, and then move on to the next question. I do that all throughout the quant section. So I have my yellow pad all set up generally, as I mentioned, in multiples of 8. So working up from 0, it's 0, 8, 16, and so on. When I get to the very first page, it's just 3 questions because the total number of minutes isn't actually a multiple of 8. This is something that you can check out and learn about in more detail on our blog and our GMAT forums. If you search for yellow pad technique, they lay out how to set up the yellow pad and how to use it to help manage your guesses throughout the GMAT, and it's super helpful. It's the #1 thing that helped me improve my timing on the GMAT. What other general questions do you have? I see one in my question bank here. Are there additional classes every week on the site? Yes, there are. We have a free prep hour every week that you are welcome to attend. Q42 to Q47-ish tips. Michael, do you mean for like getting from Q42 to Quant 47, or for someone who's currently performing in that range? Can you clarify a little bit? Andrea, any recommendations for what to focus on with 2 days left to study? Great question. Andrea, I would strongly recommend focusing on getting a really strong timing strategy in place and just practicing that timing strategy. Look at your practice test or your old test data and determine what sort of categories of questions are best for you to guess on. If you need to guess, what are the ones that you want to slow down and make sure that you get right? That's based off of categories that you should guess on would be ones that you sort of miss the most historically. Ones you want to slow down and get right would be ones that you tend to do well on historically. So you want to make sure that you're slowing down. 2 days left to study isn't a great time to try to learn a bunch of new material, but you want to be reviewing your flashcards and doing what we call mixed review, which is just taking problems from the official guide or from the GMAT software and mixing up the topics and using the yellow pad technique to solve them in a timed fashion. So take 8 problems, give yourself 16 minutes, make it 4 problem solving, 4 data sufficiency, and then review. Okay. Awesome questions. Thank you, everybody. If you have more questions, feel free to email me, abell@manhattanprep.com. But this is the end of the free prep hour, so thanks for joining.